is director of the Center for Brain and Cognition and professor of neurosciences and psychology here at UCSD. He's also an adjunct professor of biology at the Salk Institute. Rama trained as a physician and obtained an MD from Stanley Medical College and subsequently a PhD from Trinity College at the University of Cambridge, England. And I think it's this wonderful combination of an MD and PhD that makes him such an intriguing thinker. Rama's early research was on visual perception, but he is best known for his work in neurology. He has received many honors and awards, including a fellowship from All Souls College, Oxford, a gold medal from the Australian National University, and the Ariane Kappers Medal from the Royal Netherlands Academy of Sciences for landmark contributions in neurosciences. In 1995, he gave the Decade of the Brain lecture at the 25th Annual Silver Jubilee meeting of the Society of Neuroscience, and more recently, the inaugural keynote lecture at the Decade of the Brain conference held by NIMH at the Library of Congress. He also recently gave a very important public lecture at the Getty in Los Angeles. I hope you note these numbers, the 10th anniversary, the 25th anniversary. 40 years ago when this campus was founded, neurosciences was not this robust field of scholarship and research that it is today, and Rama's helping to define just what that field is. A couple of other things about him. I said he's published more than 120 papers, and I'm going to spare you hearing the titles of all of them. But he's also written for Scientific American and is editor-in-chief of the Encyclopedia of Human Behavior. He's author of the critically acclaimed book, and the kind of book most of us would be comfortable reading, Phantoms in the Brain, that has been translated into 8 languages. That book formed the basis for a 2-part series on Channel 4 TV in the United Kingdom. His work is featured frequently in major news media, including NPR and Dutch television, and Newsweek magazine recently named him a member of the Century Club. This is quite extraordinary. One of the 100 most prominent people to watch in the next century. We're privileged to spend a couple of hours with you tonight, Rama. We'll watch and listen.
The lecture is going to be mainly about art and the science of art. There's already an oxymoron there. When most people think of art and science as completely antithetical. And it seems like a travesty to even ask, can there be scientific principles underlying art? But that's going to be the main theme of my lecture. And I'm going to try and develop a neurological theory of artistic experience. Next slide. But before I do that, various collaborators involved in this research, Eric Altschula, who's a postdoc in our lab, various others, including my wife Diane, who's here. And some of you may have guessed that this slide was made and supplied to me by Eric Altschula. To this list, I might also add Mary Beebe at the Stewart Collection, and also Kathleen Stoughton with the University Art Gallery. I've had many conversations with them about art, and of course Julie. Can we have the next slide? Okay, now, what I usually do for a living is not art. I just dabble in art, you know, and I collect a little bit of art. Mainly, I do neurology. And to give you some idea of the sort of thing that we do, I'm going to tell you about an example of a very fascinating neurological disorder. What we do is look at patients who have had damage to specific parts of the brain, and there's been a change in the behavior, change in the mind. And then you study the patient in detail, and then you ask yourself, what can this tell you about the functions of the normal human brain? So that's the name of the game. You're playing Sherlock Holmes, studying these patients, okay? Now let me tell you about, there's an extraordinary syndrome called prosopagnosia. What this means is there is bilateral damage to the temporal lobes. That's the brain, frontal lobe, temporal lobe, parietal lobe, occipital lobe. When there is bilateral damage to the medial inferior parts of the temporal lobes, you get a syndrome called prosopagnosia, which means this person who's had a stroke damaging a fairly small part of the brain is suddenly incapable of recognizing people's faces. He can still read a newspaper, so there's nothing wrong with his eyesight, but he can't look at somebody and say, this is Joe, this is Susan. In fact, he can't even identify his mother. In fact, he can look inside a mirror and he doesn't know it's him. Well, he kind of knows it's him because when he winks, it winks back, you know. But it doesn't look like him. Okay, this is called prosopagnosia. But there is another syndrome. Prosopagnosia is very well known and it's been studied extensively by neurologists. And I have this habit of going after curiosities, anomalies, things which nobody else finds interesting. Okay, there is one extraordinary syndrome called Capgras syndrome, which is so rare that even most neurologists have not heard of it. This refers to patients who are otherwise normal, sometimes in a psychiatric setting, but sometimes just after a head injury. The guy's been in a car accident and maybe has been in a coma for a couple of weeks and then comes out of the coma, seems quite normal, fluent in conversation, not emotionally disturbed, not hysterical in any obvious way, seems quite normal except that he has one profound delusion. He looks at his mother and he says, doctor, this woman looks exactly like my mother. You know, he looks exactly, but she's not my mother, she's an imposter. She's pretending to be my mother. Okay? It's a replica. And he says this with a perfectly straight face. There is nothing else wrong with this guy. Okay? He can read a newspaper, he can talk to you about politics, he can talk to you about the Monica Lewinsky case, he can talk about anything you want. Okay? But when he looks at his mother, he says, this is an imposter, some other woman pretending to be my mother. How do you explain this extraordinary syndrome? The standard explanation is Freudian, and you find it in most psychiatry textbooks. And that is, this young man, when he was a baby, when he was an infant, like most infants, like all of us here, and the same argument applies in reverse to women, but I'll just talk about men. When you're babies, you had a strong sexual attraction to your mother. This is called the so-called Oedipus complex of Freud. Okay? I'm not saying I believe this, but I'm saying this is the standard view, okay? Then you grow up, and then you repress these forbidden sexual urges. Thank God, otherwise all of us would be sexually aroused by your mother, okay? And then along comes a blow to the head, bang, and these repressed sexual urges come flaming to the surface. And then you say, my God, if this is my mother, why am I feeling sexually aroused when I see her? Okay? She must be some other strange woman, maybe it's pheromones, who knows what it is. This is the standard explanation, and it's a very ingenious explanation, as indeed most Freudian explanations are. Okay? But it doesn't work, because I've seen patients with Capgras syndrome who have the same delusion, not about their mother, but about their pet poodle, about their dog. Now you think about it, how does the Freudian explanation work here? Okay? You can start talking about the inherent bestiality in all human beings, or something like that. But it simply doesn't work. And then I thought maybe there's a simpler explanation for this syndrome, namely, we know that in the temporal lobes there's an area called infratemporal cortex, which is concerned with just processing faces, recognizing faces. When that's damaged, you get prosopagnosia, you can no longer recognize people's faces. But when you look at any object in the world, it's processed there, and then it gets sent to the amygdala and to the limbic system, which are the emotional centers of the brain. So you're emotionally aroused by what you're looking at. If it's a slide projector, obviously you're not emotionally aroused. If it's you know, a light there, you're not aroused. But if you look at a mother, you say, wow, it's my mom. You know, there is this warm glow, or this terror, as the case may be. Okay? When you look at your mother. When you look at somebody else who you've never seen before, there is no emotional arousal. So what I said was, maybe what's wrong with this guy is, maybe the face area is normal. That's why he can still say, yeah, it looks like my mother. It looks like my mother. But the message doesn't get to the amygdala because this wire is cut because of the head injury. So he looks at his mother and he says, if it's my mom, why don't I feel anything? There's something weird here. It must be some other strange woman. That's the only explanation that makes sense to him, given this disconnection I'm talking about. Now, how do you test this? Well, you can test it very easily by using what we call a galvanic skin response. When any one of you, if I show you computerized images, images on the computer of different objects, a slide projector, the message gets processed in the visual centers, in the temporal lobes, and you identify a slide projector, goes to the amygdala, which gauges the emotional significance of what you're looking at. My God, is this a predator? My God, is this a mate? Is this my mom? or is it just a slide projector? I can ignore it, okay? The amygdala does that, and then it cascades into the rest of the limbic system, into the hypothalamic nuclei, down the autonomic nervous system, okay? Down the autonomic nervous system. And then what happens is your skin starts sweating, your heart starts pounding, you prepare the body for fighting, fleeing, feeding, or sexual behavior. Okay? Your body gets prepared for action. Your heart starts pounding, and your skin starts sweating because you want to dissipate heat, because you're going to be doing something, you're going to be doing something active. Okay? You can measure the change in skin resistance by putting 2 electrodes on the palm of the hand. And this measures the change in resistance. So when I put any one of you here in front of the screen and show you a slide projector, there's no change in resistance. But if I show you a stranger, there is no change in resistance. But if I show you your mom, you say, wow, mom, okay? Instantly, it cascades in and it makes you, believe it or not, every time you see your mom, you sweat. All of you here, okay? Whereas if I show you some stupid, inanimate object like the slide projector or something like a shoe or something like that, nothing happens. Unless you have a shoe fetish, then you can, that's a different matter, okay? Now, what about our patient? So we had a patient, he came into our office, and I hooked him up to the galvanic skin response. I showed him slide projectors, nothing. That's obvious. I showed him tables and chairs, nothing. I showed him people he has never seen, nothing. Then I showed him his mother, nothing. No galvanic skin response. Whereas any one of you here in the audience, if you see your mother, you get a huge, big galvanic response. This supports our argument that there's been a disconnection. Now, the reason I'm telling you about this syndrome is it's a striking example of cognitive neuroscience, the power of this whole new approach to neuroscience, to the brain, and that is you can take a completely bizarre, seemingly incomprehensible neurological syndrome. Seems almost like the guy is nuts. Seems like a psychiatric syndrome. You know, the guy is saying his mother is an imposter. And then say, no, the Freudian explanation is wrong. There's a specific disconnection here between the amygdala, the emotional centers in the brain, and the visual centers in the brain. And that's what explains his curious predicament. And then you can spend 1 hour doing an experiment and show that that's what's gone wrong in his brain. Okay? So that's what we're doing. Okay? Now, let me tell you about another very curious syndrome. Next slide. This is a syndrome that has been, it's not really a syndrome because it's seen in normal people. Goes back all the way to the 19th century. The Victorian scientist Francis Galton, who's a cousin of Charles Darwin, noticed that some people, completely normal people, otherwise normal, when they hear certain tones, they see specific colors. This is called synesthesia, the merging of the senses. Specific tones, specific colors. Similarly, when they see specific numbers, the number 5 is always red. Number 6 is always green. Number 7 is always blue. Maybe there's somebody in the audience who sees this. Galton also said this runs in families. Okay, so it's genetic. Okay? Everybody ignored this paper. And as often happens in science, there have been many reports of people with synesthesia, but people thought it was a curiosity. It's an anomaly. Some bizarre, I mean, why would anybody say 5 is red? And people said, well, maybe it's just memory association from childhood. You know, when they were in kindergarten, they saw 5 as red. So they remember that, they got stuck with it. So when they see 5, they see red. Or maybe these people, when they say C major is green, they're just being metaphorical. Right? Like, for example, you may say cheddar cheese is sharp. Now, cheese isn't sharp. If you rub it on your hand, it's soft. But you said, no, 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 it's a metaphor. Its taste is sharp. But how can taste be sharp? Sharp and dull are skin, touch. It's nothing to do with taste. So why do you use a metaphor? Okay? But people said, oh, you know, synesthesia, they're crazy. They're just, you know, they're on drugs. They've taken LSD. Maybe they're potheads. Or maybe they're just being metaphorical. Now, this is a classic example in science of trying to explain an enigma using a metaphor. And that never works. Okay? You can't explain one mystery using another mystery. Saying synesthesia is just metaphor. Who knows what a metaphor is? Right? Nobody knows how metaphors are represented in the brain. Right? So that's not an answer. So we said first thing we need to do is to study these people and see what's going on in the brain. First of all, is it a real phenomenon? Are they just making it up? Are they just potheads? Or is there a real phenomenon here to study? So what we did was an experiment, which I'll show you briefly with my overheads. Now, there are some synesthetes who, when they see the number 2, they see red. But then when they see the number 5, they see green. Okay? Normal people, you look at this, it all looks like gobbledygook. But what you do is you arrange the 5s to form some shape like a triangle or a circle. The synesthetic subject, and we had 2 subjects who we found who had synesthesia. This is much more common than Galton thought it was. About 1%, 0.5% of the population has synesthesia. I just went to my class, which is 300 students, and said, does anybody experience this? And 2 hands went up. Okay? So it's much more common than people realize. And just for fun, let me, one of these subjects, whose name was Esmeralda, and I'll just say, this subject saw 5s, because we don't like to use real names, 5 as red and 2 as green. Now when she saw this, instantly she saw a circle or a triangle or whatever shape that was embedded. This shows that this is a genuine sensory or perceptual effect. It's not some memory association or metaphor or childhood memory. How can that enable them to see the triangle do something better than all of us here? That means they're actually literally seeing the color. That 5 looks red to them. Okay? Another thing people have noticed is synesthesia is much more common among artists and poets and creative people. We don't know if this is true. We're studying this. But there's a lot of anecdotal evidence that this is true. I'll come back to that in a minute. Okay, so it's a genuine perceptual sensory phenomenon. It's not about memory. We know that from this experiment, this crucial experiment. Next question is, where is it going on in the brain? Next slide. Here, Ed Hubbard and Eric Altshuler and I, we've been studying this. It turns out there's a structure in the temporal lobe called the fusiform gyrus, and you see that green dots there. That's the color area of the brain. It's been identified by Semir Zeki. Cells there respond to color. It's specialized just for color. It's not doing anything else. Now, this red outline represents the visual numerical grapheme area. 1, 2, 3, 4, 5. They're right next to each other. So what I'm arguing is there is some cross-wiring in these unfortunate or fortunate few. Okay? And that's why when you see 5, they see red. When they see 6, they see green. There's some cross-wiring. Remember, it runs in families. And it's true of the 2 subjects we tested. Their parents had it. So there is a gene mutation that causes defective pruning of connections in the fetus in early infancy. So some areas are left with redundant excessive connections. Okay? And the penalty is when you see 5, you see red. When you see 6, you see green. Now, that's the penalty. But the bonus is, what is a metaphor? A metaphor is taking 2 completely unrelated ideas and developing a link. Maybe these people have much more associative wiring than normal people. That's why they're good at poetry. That's why they're good at visual art. Okay? This is all speculation, but it's something that we're pursuing, which we're studying in detail. Okay? Now, the wonderful thing about this hypothesis is, Ed Hubbard, who's a student in our lab, you can do fMR. You can take people, patients. This, by the way, is his brain, you know, which is comforting to know that he has a brain. Okay? and that there is Zeki's V4. That's the number area. And we can now see, if you just show him numbers, will the color area also light up in this guy? So you can go from the gene, if you get a large enough population, large enough family, you get a gene, the specific brain anatomy, specific phenotype, okay? And now I get to the most exciting part, and that's about metaphors. What is a metaphor? Supposing you say, Shakespeare says, it is the east, and Juliet is the sun. Wow. You don't say Juliet is the sun, she's sort of flaming ball of fire. Schizophrenics do. Okay? They don't understand metaphor. But normal people say, oh, like the sun, radiant like the sun, nurturing like the sun, warm like the sun. That's what Juliet is. And Shakespeare was a master at this. Okay? What's going on there? So what I'm arguing is, maybe these people, some people have more wiring, cross-wiring. This enables them to link seemingly unrelated things more readily, more easily than you and I. That's why Shakespeare could do it so beautifully. For example, if I ask one of you here, how do you think of an analogy for hyperbole? Exaggerating something, overdoing it, overdoing something. Think of an analogy for overdoing something, right? You know, I sit here thinking for about half an hour, I may come up with something, but something crummy. Shakespeare had 3 in one sentence. To add another hue to the rainbow, to gild refined gold, to paint the lily is wasteful and ridiculous excess. He thought of 3 in one sentence. How? None of us can do it. I think it's because he's got more wiring. So synesthesia is a phenomenon. People used to say synesthesia is bogus. You know, it's an anomaly. You know, it's just a metaphor. I'm saying the opposite. I'm saying turn the problem upside down. We're all synesthetes. And by studying these people with this problem, you can understand how we create and represent metaphors in the brain. Okay? Think of an example. For example, if you say something smells and tastes disgusting. So feces, sorry to mention this, but feces or something foul smelling, you say, ugh, disgusting. And you make an expression. And in fact, Darwin showed that an infant does this. A newborn infant will do this for feces. Why is it for social disgust? Somebody does something disgusting. You know, maybe peas here or something. I'm sorry, I can't think of a good example. Or you say disgusting. Ugh. Why do you use the same word? In every culture, in every language. And you know what disgusting means? Gustatory. It means taste. Well, the ventromedial frontal lobes are where the smell, olfactory lobes project to, for disgusting smell and taste. It's phylogenetically very ancient. And then mammals developed social behavior. Where is social behavior? Social disgust, also in the ventromedial frontal lobe. And I'm arguing it's not a coincidence. It has to do with the economy of brain wiring. You use the same area to represent both kinds of disgust. And this can be tested experimentally. Is it a coincidence that whenever you use violent, you know, you want to say something, you know, I don't want to use that 4-letter word, you say F you. Okay? What's a connection between sex and violence? After all, sex is a pleasant thing. Why do you connect? You don't say bite you. Okay? I bet there is something in the hypothalamic nuclei that the sexual centers are right next to the violent centers, and there's some cross-wiring there. That's what's going on. Okay? So the reason I'm telling you about this syndrome is it's just giving you an example of the sort of research we do. You can go from the gene to the brain area to the phenotype and visual perception all the way to Shakespeare and metaphor in one preparation. That's what makes it exciting. Now let me come to the main part of the talk. Next slide. Now I'm going to talk about art, but before I do that, first of all, you need to understand a little bit about perception and vision, because there are a lot of misconceptions about perception. If you don't understand vision and perception, you're not going to understand art. Okay? The most serious misconception about vision is, for example, I was taking a flight from San Francisco to San Diego on Southwest, and I was sitting next to a priest. And he said, "What do you do for a living?" And I said, "Oh, I study perception, I study vision. I'm interested in how the brain sees an image." He said, "What's there to study?" And I said, "Well, what do you think happens when you look at this cup of tea?" He says, "Oh, well, you know, there's an upside down image in the brain, in the eyeball, you know, because of the lens. Then it goes through the optic nerve, and then there's a area called visual cortex, and it's displayed there." Right? Now, he was surprisingly sophisticated for a priest, you know. Sorry, he knew there was an image, there was a thing, it was displayed and all that, okay? But there's a serious logical fallacy. He says, "Oh, that's how you see something." Because if you send the image and display it on a screen here, then you need another little guy in here looking at that image. And then you need to go into his brain, and you need another little guy in his brain looking at that image. Ad infinitum, until you get an endless regress of eyes and images and little people, and you don't solve the problem of perception. So the first thing you have to understand when you're thinking about perception is there are no little people in the head. This is just a cartoon diagram, right? There's no cinema screen, there's no people watching, okay? What you have is symbolic descriptions. In fact, Well, then you say, Dr. Ramachandran, how do I know that? Maybe there is a picture here. How do you know that's right? Well, let me show you some evidence. Next slide. Well, look at this famous Necker cube. This is a skeleton drawing of a cube. And you can either see it like that or like that. You can flip it mentally. How many of you can flip it? Raise your hands. Wonderful. There are an unfortunate few, and I'd love to see if they have a gene mutation somewhere. But okay. Now that's important because it's an image that's constant on the eyeball. Nothing is changing. But your interpretation changes completely into this and this. Next slide. The mother-in-law, daughter-in-law figure, pardon me, okay? Or the old lady, young lady figure, or the mother-daughter figure, okay? You can see this as a young lady, that's what most men see, right? With a chin and a dainty nose and a necklace, a fur coat. Or you can see it as a hideous old hag. How many of you see the alternation? Those of you who haven't seen the old lady, the young lady's chin, sorry, the young lady's neck is the old lady's chin. The young lady's chin is the old lady's nose with a big fat pimple on her nose. Okay? How many of you see it now? Okay, excellent. Now here again, the image is constant. Nothing is changing. But your perception changes. What does this mean? This means perception cannot involve just taking an image, displaying it on a screen in your brain. Because if it were, it has to stay the same. It means that perception involves active interpretation by the observer. It means that it involves every act of perception involves judgment. It involves an opinion on the state of affairs in the world, not a passive reaction to what's coming in. And this is just a striking example of that. Next slide. Another example, you all see banisters, but how many of you, Mel Green there, how many of you see nudes? Okay, you can see it as nudes facing each other. I'm sorry? Father-in-laws, okay. Next slide. You can see that as a person looking at you, or the very despondent kiss. Two people in profile kissing each other. How many of you see that? Raise your hands. Excellent. Next slide. Okay. How does all this happen? Well, it turns out in the back of the brain and in the sides, you've got 30 areas, 30, concerned just with seeing, just with vision. Primates are highly visual creatures. Each of those areas is concerned with a different aspect of vision. There's an area for color vision. There is an area for form and shape. There's an area for depth, relative distance. There's an area for just movement. There's an area for color. There's this exquisite specialization. And that's because vision is much more complicated than anyone ever imagined. And that's why art works, because if you can simply vision involves an image going to the brain and being displayed on a screen, an artist would be out of business, right? The reason art works, he goes in there, he changes the image, plays with it, and titillates these visual areas in your brain more optimally than just looking at the real world. And that's why you get this high. And that's called art. That's Ramachandran's definition of art. Okay? Now the question is, how does he do it? Okay, next slide. That brings me to the art part of my talk, the main part of my talk. And the question is simple. Are there artistic universals? What I mean by that is, despite the staggering diversity of artistic styles, there is Renaissance art, there is Impressionism, there is Expressionism, there is Cubism, there is Fauvism, there is Indian art, there is Tibetan art, there is Dada, which is not even art. There is all kinds of art, okay? But in spite of this staggering diversity, could there be some underlying common principles? After all, there are thousands of languages. If you speak French, it doesn't mean you understand Hindi. But according to Chomsky, there is a universal grammar that's universal. Is there a universal grammar for vision and for art? That's what I was interested in as a scientist. And if so, how does the brain respond to art? These are, of course, two sides of a coin. Next slide. Now, to put it in historical perspective, I'm from India, from a little town called Mylapore, which goes back to the 4th century BC. And that temple, whose foundations go back to the 3rd century BC. And I want to tell you how I got into art, because mostly what I do for a living is neurology. And I just dabble in art, and I sometimes collect art. And I want to say that until about 5 years ago, I had absolutely no interest in art. I mean, I take that back. I mean, you know, I'd go to a city, new city, for a conference or something, and there's an art gallery there, there's a show. I'll just go and see it, you know, just to show that I'm very cultured and that sort of thing, you know. I'll go there. But I did not have any passion for art. There's a big difference between interest and passion. I did not have a passion. And then, next slide, I'm going to acknowledge some other people who are involved in the art project, especially my postdoc, Bill Herstein, who I had lots of conversations with, my wife, Diane Rogers Ramachandran, with whom I would wander the temples in India, and I'll get back to that in a minute, and we were intrigued by these sculptures of gods and goddesses. And Julia Fuller-Kindy, some of you may know here from the Stewart collection, who was giving some lectures on Picasso and Rodin, which I went to, and was inspired by these lectures and said, why does the brain respond to art? I mean, what is it about art that turns us on? Okay? And then I went to the temples in India on a sabbatical for 3 months, and we were wandering around these temples, and we was looking at these sculptures of gods and goddesses. You know, I said, why are these images so hauntingly beautiful? Okay? Because my initial reaction was, I grew up with these images, praying to these gods and goddesses, raised as a Hindu, right? And I had a colonial view of this art. I used to think this is religious iconography. You know, this is about mythology and religion, right? To put it in historical perspective, next slide, I looked at the history of Indian art and Western reactions to Indian art. When the English first arrived, the colonials arrived in India, many of the art historians and art scholars looked at Indian sculptures, like this bronze statue of the goddess Parvati from probably 11th or 12th century. She is supposed to be the wife of Shiva and supposed to be the epitome of feminine sexuality and grace and dignity and poise. She's a goddess. The English looked at this, and he said, the Victorian Englishman, he said, yuck. You know, that doesn't look real. Look at the breasts, they're too big. Look at the hips, are too big. You know, and the waist is too thin. That doesn't look realistic. It's paganism. It's primitive art. It's not really art. Okay? Next slide. And he also looked at the Rajasthani miniature paintings. He said, yuck, there is no perspective here. You know, it's not realistic. Now, of course, in making this criticism, he has missed the whole point of art. Because the point of art is not realism. Right? The point of art is not realism. You can take a $5 camera and click, you know, take a naked picture of somebody here. Nobody would pay you $1 for it. Okay? Unless it's a picture of Mel Green, then you might pay a lot of money. Okay? But normally, nobody would pay you a cent for that. The purpose of art is not copying reality. Is not realism. The purpose of art is hyperbole, is exaggeration, is distortion, is to deliberately distort the image to produce pleasing effects in the viewer's brain. That's the purpose of art. Okay? It's not realism. Because you can take a photograph of somebody, nobody calls that art. Okay? Next slide. The irony is, next slide, come the 20th century and Picasso comes along. What does he do? He produces distortion. He's got this this woman here, 2 eyes on one side of her face, looks like a flounder, right? And you know, it's got a club foot and everything is distorted. And what did the Western art scholars say? My God, what a work of genius, because he has liberated us from realism. Well, guess what? That's what the Chola bronze artist was doing. He knew what a real woman looks like. He said, to hell with a real woman. I want to produce something that is evocative, produces emotions in your brain. He was distorting it deliberately. Okay? And that's what Picasso was doing, not to detract from Picasso's genius, but simply to say that he's reinventing the wheel. This was known 1,000 years earlier in India. Next slide. And same thing with somebody like Matisse. Look at how that's perspective correct, oval, but the table is circular. Completely wrong. The perspective, any idiot will tell you that perspective is all wrong. But you say, oh my God, Matisse, he's a genius. You don't say, oh God, yeah, the perspective is wrong. Because the point of art is not realism. He is playing with colors. Well, guess what the Rajasthani miniature painting is? Again, he's playing with colors. A whimsical use of color is not about realism. Okay? Next slide. Even greater irony, the same Englishman who was looking at those bronzes and saying, yuck, they're primitive, the hips are too big, the breasts are too big. Guess what his wife was doing? Okay? This is the time when corsets were introduced in Victorian England. And grotesquely pinched waist. I have seen skeletons of these women, believe it or not, at the Hunterian Museum of Royal College of Surgeons in London. They had ribs removed to constrict the waist. It may have even been inspired by those Chola bronzes, which that Englishman saw. So he was encouraging his wife to do it and admiring her beauty and saying that the Chola bronze was primitive art. Okay? Next slide. If you want realism, there it is. Right? Nobody calls that a great work of art. I mean, he's cute, but nobody says it's a great work of art, right? Now, speaking of, sometimes I give these talks, and every now and then somebody will get up in the audience and say, but did the Chola bronze artist who created these distorted women, how do you know he was doing it deliberately? Maybe he didn't know what a woman looks like. You know? Maybe it is primitive. Maybe the miniature painters didn't know what perspective is. Maybe it is primitive. Well, let's go back to 2500 BC in India, in the Indus Valley. That's a torso from 2500 BC, incredibly realistic and beautiful. In fact, it's more realistic than that Renaissance Michelangelo you saw, because that's what real men look like. Look at that belly, okay? Not like that group, you know, that god you saw earlier, okay? So Indian artists knew perfectly well what realism is, and in fact went on for thousands of years, and then they went into abstraction, distortion, deliberately to evoke emotions. Next slide. Okay. Now, if you come to medieval times, so question is, clearly art involves distortion. It involves hyperbole. It involves exaggeration. But you can't just randomly distort something and call it art, although some people do, okay? Especially in La Jolla. But so it has to be a specific type of distortion, a specific type of exaggeration. What is it? Well, if you go to the 3rd century BC, the first millennium BC, the sage Bharata, who wrote a big treatise on aesthetics and art, uses a word called rasa, R-A-S-A, which is a word that appears frequently in Sanskrit. The Sanskrit word rasa is difficult to translate. What it means is the spirit of something, the soul of something, capturing the very essence of something to evoke a specific emotion in the viewer's brain. That entire sentence is encapsulated in that one word, rasa, right? So for example, the medieval stone sculptor in Khajuraho, 9th century, 10th century, will speak of the rasa of amorous ecstasy. This is two celestial lovers. Look at the way they're gazing at each other in everlasting rapture, intensely absorbed in each other. But look at the way he's holding her chin and raising it towards him, saying, "You're mine." Okay? Look at the way she's holding his hand, tight. So there is this palpable erotic tension being built up in the image, even as you watch it. And that's the goal of that sculpture, to evoke eroticism, intense eroticism, the rasa which we call Sringara rasa. Okay? It's not to say, oh, let's make a real looking man. You don't say, oh, the ears are too long, you know, the fingers are too long. That's not the point of art. You can do that with a camera. You don't want to go and just take a click, two people necking, right? All right? This is art, right? It's to evoke that emotion, right? Next slide. This is another rasa, and that is, I'm using the word rasa a little bit loosely, but this is conjugal bliss instead of erotic sexual intimacy. Not necessarily incompatible, okay, but very different mood. This is Vishnu and Lakshmi, his celestial consort, his wife, in heaven. Look at the way they're so comfortable with each other. But yet there is a little bit of understated sexuality. Look at the way his hand, which is broken, is holding her breast. Her hand is draped around his neck. So there is this wonderful sense of intimacy. Look at how the lines just flow into each other. This wonderful sense of intimacy, and they're just sort of looking at the universe, at all of you lesser mortals, you know, because they are in charge, okay? So that is conjugal bliss, the rasa of conjugal bliss, not erotic intensity. Next slide. The rasa of maternal bliss, the woman playing with her child. Look at her expression. The wonderful expression which combines joy with pride. That's what a mother's expression is with a child. Combining joy. And the sculptor has brilliantly evoked that, combining joy with pride. It's very difficult to do in stone, okay, as she's playing with her infant. Then I started thinking, what is rasa? If you understand rasa, you understand art. And I came up with what I call the 8 laws of artistic experience. Originally I only thought of 7, but then I thought of another one, 8, okay? This is meant to be playful. It could be 8, it could be 10, who knows, okay? But the idea is that there are certain rules of thumb or heuristics, and I like to call them laws. They're not like laws of physics. They're really rules of thumb, that the artist unconsciously or consciously deploys to optimally titillate the visual areas in your brain, to produce pleasing emotions. How does the artist do this? That's what I'm after. So I came up with 8 laws. I'm only going to tell you about 3 or 4, given our time limitations for another 15 minutes, okay? The first principle is the peak shift principle. What do I mean by that? Next slide. This is based on experiments on rats, operant conditioning, Skinnerian conditioning. Imagine you train a rat to distinguish a square from a rectangle. So every time it sees a rectangle, it gives a piece of cheese. But when it sees a square, you don't give it anything. Very soon, it starts liking the rectangle. Although, you're not supposed to say that if you're a Skinnerian, okay? It goes towards the rectangle, okay? Now, the interesting thing is, once it has learned to like the rectangle, later, after it's learned, you show it a longer, skinnier rectangle, it actually prefers this to that. It actually goes here. Now you say, that's kind of stupid. Why does the rat prefer this to what you taught it? It's not stupid at all, because what the rat has learned is a rule, rectangularity. The greater the aspect ratio, the more rectangular, the better. And so you give it that, it says, wow, what a rectangle. Right? And it goes there, okay? Now you say, my God, what the hell does that have to do with art? Well, let's go back, let's think of caricature. What do you do in a caricature? Supposing you want to have a caricature of Nixon. What do? You want to know how is his face different from the average male face. So what you do is you average all the male faces, you can do this with a computer, subtract the average male face from Nixon's face, and that tells you what's special about it, the big nose and the shaggy eyebrows, and then you amplify the difference. And then you get a caricature. You get the rasa, the Republican rasa, okay? You get the rasa of being Nixon, okay? So it looks even more like Nixon than Nixon himself, right? That's the key idea. Now if you overdo it, it looks comical and you call it caricature. But if you do it just right, you get a beautiful portrait. You get portraiture, you get Rembrandt, okay? Next slide. What about the Chola bronze? Well, what's he doing? The epitome of feminine sexuality, grace, dignity, poise. How do you do that? Well, what he does is, he takes the average male form, the average female form, subtracts the male from the female, you're going to get big breasts, big hips, narrow waist, and he amplifies it. When he amplifies it, you don't say, yuck, that's abnormal anatomically. You say, wow, what a woman. Okay? At least the limbic system in your brain is saying that. Okay? Now, then you say, well, that's only going to produce a sexy woman. What about dignity, grace, poise? She's a goddess. Well, what you do is, there are some postures that men simply cannot adopt because of pelvic anatomy. The angle between the neck and the shaft of the femur, and the way your spine is articulated. I mean, I can't even stand like that if I want to, if I try. Whereas a woman can do it effortlessly. So what you do is, you go into an abstract space I call posture space, and you exaggerate that feminine grace, elegance, poise, and that's what she's doing. Okay, that's what she's doing. And there's this wonderful sense of, she's erotic, she's sexual, and yet great dignity and great poise, right? She's holding that phantom lotus flower in her hand. And even as you watch it, there's something I want to tell you about a lot of Indian art, including Chola bronzes. There's a strong exposure effect. It's like what we used to call in psychology the Chinese face phenomenon. When the Chinese first came into this country, all Chinese looked alike. Now, of course, they don't look alike, right? The reason is your brain does not have the sensitivity to the parameters that distinguish Chinese faces. So they all look alike. You go to Berkeley, the Chinese students say all Caucasians look alike, okay? Because the majority of them are from China, or sorry, the Chinese, okay? Same thing with Indian art. Your brain develops a sensitivity to the parameters that the artist is using, and then it's hauntingly beautiful. Not only that, every time, I've given this lecture about 30 times. Every time I see the slide, it gets better. So, my God, first time. Second time, my God! You know? It gets better and better. Unlike kitsch art. This is how you tell kitsch art apart from good art. Kitsch art, La Jolla art, you go look at it. Second time you say, Third time you say, You know. Great art, like Beethoven's Fifth, each time you hear it, it becomes better. Each time. That's the truth of Chola bronze. Okay? Next slide. Another example of a celestial nymph from Madhya Pradesh, probably around 10th century, 11th century. And big breasts, of course, and big hips and narrow waist. But there's another clever trick the artist has used. Look carefully. Look at all these folds of fat, these rolls of fat on her abdomen. And you say, yuck. Why is fat beautiful? Fat is ugly. Well, that's because we live in a society where models are anorexic. Okay? But if you look at our hunter-gatherer ancestors, having fat's very sexy because it means you can nurture the baby and feed the baby. So this, what she's telling your limbic system is, come and mate with me. I can feed your baby. Okay? I've got plenty of fat stores. But at the same time, he doesn't want to make her obese. He wants to preserve that hourglass figure, accentuated hips and breasts, and yet give her plenty of subcutaneous fat to nurture the baby. And these are all, even that vertical line going through the umbilicus, the belly button, is a very clever trick that the artist has used. These are all things you don't realize consciously. It's appealing to your limbic system and to your right brain. Now, by the way, going back to posture, remember I said here's a celestial nymph from the Metropolitan Museum. It's gorgeous. The sense of movement. See how the necklace is flying off? Of course, big breasts, big hips, narrow waist. You don't say, oh, no, that's anatomically incorrect. You know, you say, wow, what a nymph. The sense of movement, the dance. Okay, that's poetry in stone. It's brilliant. Okay, next slide. Now, by the way, this is not just true of Indian art. If you go back to ancient cave art, for example, European ancient cave art, look at these bisons. Beautiful. But they've got these teeny weeny skinny legs, tiny microcephalic head. Okay? But you don't say, God, that's ugly, it doesn't look like a real bison. You say, wow, beautiful. Because it's a rasa of bisonhood the artist has captured. Okay? Now you say, oh, fine, Dr. Ramachandran, it's all fine and dandy about the human female and the male and all that and posture. What about the rest of art? What about Henry Moore? What about Rodin? What about Klimt? What about Impressionism? What about all that? Well, I'm getting there. Okay? Now, to understand abstract art, or even semi-abstract, you have to go to ethology. So one of the things we're trying to do is to take evidence from many different sources and weave it together. Okay? Nobel Prize-winning ethologist Timbergen at Oxford 30 or 40 years ago studied seagulls. This is a herring gull with a beak with a red spot on it, yellow beak, red spot. You can see this even on our coast. The chick, the baby seagull, comes and begs for food by pecking at the red spot. Now the question, how does the chick know, how does the chick recognize the mother? So what Timbergen did was, he just took a disembodied beak with no mother, and this old guy with a beard, went and waved this beak in front of the chick started begging for food from him, thinking he was mom. So that's kind of stupid. I mean, here's this guy waving this beak and it thinks it's mom. It's kind of stupid. It's not stupid at all, because what it's telling you is vision. The visual mechanisms in the brain have evolved to economize on information processing. Do as little work as you need to do to identify the object. Now, the chick's brain knows, through millions of years of evolution, the only time it's going to see a long thing with a red spot is when mom is around. So to hell with the rest of the mom. You know, why waste processing, computational power, processing all that? Whenever I see the red spot, I'll beg for food. Okay, so it's not stupid at all. Now, this means you can easily fool the chick, but the chick can get away with using the shortcut because it's never going to run into a mutant pig with a beak, or a malicious ethologist waving a beak in front of it. Okay? So it can capitalize on this redundancy in nature and take advantage of the fact that this is always seen with mom. Next, Timbergen found you don't even need a beak. You take a long stick with a red spot, the chick gets fooled. Because the neurons in the visual pathway, they have some coding scheme, some way of encoding the shape of that beak, and you can fool it very easily, just like you were fooled by visual illusions. And the chick thinks that's a beak and goes and pecks for food. And even better, if you show it a long, thin stick with 3 red stripes, the chick goes crazy. All the chicks come there attracted to it like a magnet, start pecking away incessantly, right? We don't know why. Timbergen doesn't explain why, but he had accidentally produced a super beak. And the chicks go crazy. Okay? That's because we don't know what the form primitives are in the chick brain. What is the language, the alphabet for form perception? And maybe the neurons in the chick's brain, they are looking for a beak, they have a certain feature they're looking for, and this damn thing actually stimulates it even more, right? Because the rule might be the more red outline the better. And you give it more red outline with 3 red stripes, it goes crazy. And it says, wow, what a beak. Okay? And the message then goes into the limbic system of the chick, the emotional centers, and it's mesmerized, and it's attracted to this beak. Okay. Now, even though this beak, this stick with the 3 stripes does not resemble a beak at all, the chick goes crazy. Now that brings me to the punchline of my art lecture, and that is, if the seagulls had an art gallery, they would hang the stick with the 3 red stripes on the wall, they would worship it, they'd pay millions of dollars, they'd call it a Picasso, but they wouldn't know why, because it doesn't resemble anything. They'd say, why the hell am I so excited about this? Okay? And that's what all of you art collectors are doing in the audience. Okay? Next slide. So what I'm saying is, people like Picasso or Henry Moore have either trial and error or through intuition or genius tapping into the form primitives of the human brain and creating for your brain the equivalent of that long stick with the 3 red stripes for the chick brain. So you're all behaving like those little baby seagull chicks when you go and pay all this money and buy that art. Okay? Next slide. That's Henry Moore. Now you say, fine, Dr. Ramachandran, how do I know any of this is true? Now that's the important thing about science. What makes science different from philosophy? Philosophers have been talking about art and aesthetics for thousands of years, going all the way back to Aristotle. And guess how much progress they have made? I won't go into that, okay? Now, the reason is, they don't come up with testable ideas. What I'm saying is you can test what I'm saying. And I'll tell you how you can do that. Let's take something very specific like cubism. Your response to, let's take Picasso, right? Why is this putting 2 eyes on one side? What is cubism? Is transcending the tyranny of viewpoint. I can only see this from one viewpoint. You say no, Picasso says I'm going to drag the other side of the face and put it here. Okay? But why should that be beautiful? That's what nobody has answered. I'm going to answer that. Okay? If you go to the visual infratemporal cortex and you record from cells in that part of the brain, next slide, what you find is very interesting. This is a schematic diagram of my graduate student's brain. Okay? If you record from cells here, each cell in the face area of the brain will respond to one view of a particular person, boss. The frontal view, semi-profile, complete profile. Different cells, this cell for profile, this cell only for frontal, right? These are face cells, but only one view of the face, okay, only one view of the face. But if you go to the next area higher up, you get these master face cells, which respond to any view of the face, so long as it's the right face, boss. And you go to another mast cell, it'll be my mate. Another cell, my baby. Okay? Different cells for different faces. How do you construct these? You take the output of these, anybody here who's an electronics engineer will know this, you take the outputs of all these cells for individual views, and you pull them onto one master cell, which responds to any view. Okay? Now comes the punchline. If you put 2 views simultaneously in one image, it's going to excite 2 cells and hyperactivate that cell. So that cell's going to scream its head off, saying, my God, what a face. Okay? And then it's going to tell the limbic system, here is a super face. That's what Picasso is. That's what cubism is. You're giving 2 views and hyperactivating it, just like that long stick with the 3 red stripes is hyperactivating the chick's brain. And the advantage with this is you can go tomorrow to a lab in Oxford or in Harvard where they're doing this experiment, recording from master cells, show it a Picasso, and I'm saying it'll fire more to the Picasso than to any of these faces. And I love this example because, you know, you often have cocktails with people, scientists, social scientists, art historians, And the social scientists always say, oh, you scientists, you can explain the atom, you can explain this, you can explain brains and molecules and this and that DNA. You never explain a Picasso. Okay? Well, guess what? That's what that is. Okay? Okay? You can actually explain a Picasso. Now, you can go and do the experiment. You can come back to me next week and say, Dr. Ramachandran, you're full of it. It doesn't work. Right? But at least we know it doesn't work, and you go to the next step. That's what science is. In philosophy, you can't do an experiment and say Plato is wrong. Have you ever anybody heard say Plato is wrong? Nobody. Right? Okay? Right? Sorry? Okay. Well. There is a philosopher in the audience. Next slide. Okay, so this is just showing you what I just said. Next slide. Now, another way to do the same experiment is to do galvanic skin response. Remember I said the visual image goes in, cascades into the limbic system, makes you sweat. I'm saying if you show somebody a real Playboy pinup versus a Picasso, you should get more sweating with a Picasso, even though the pinup looks more realistic. Because I'm saying it's hyperactivating the visual areas in the brain. So these are all testable propositions. We're working on this. Next slide. Now you say, well, what about a Monet? What about Impressionism? Well, remember, you've got 30 areas which you can play with. There's a color area that represents color. So when you look at a water lily, you've got a canonical representation of water lilies in your brain, based on dozens of examples you've seen. What Monet is doing hyperbole, doing peak shift, but in color space, not in form. So you look at this, just a bunch of smudges of paint, but you're mesmerized. Whereas you wouldn't give $1 for a photograph of a water lily, because you're behaving like the seagull chick. Next slide. The second principle I want to tell you about, I've got 2 more principles to go, is grouping. And that is, look at this picture, just a bunch of squiggles and smudges. But how many of you see a Dalmatian dog? Raise your hands. Okay, many of you have seen this before. Isn't it amazing how the brain links these splotches together, knits them together in the brain, and then you say, wow, a dog. I found it. There is this aha, this insight. And that's what point people have missed. What I'm saying is, when it clicks, when you group, it's reinforcing for the brain. Why is that? The reason is, we evolved in a camouflaged environment. Those of you who are not creationists. Up in the treetops, scurrying in the treetops, dim twilight, you're trying to dodge a lion. Right? The lion is hidden behind foliage. What do you see? A bunch of yellow splotches. What does the brain do? It links, it's saying, what is the likelihood these are 7 different yellow splotches? No, they're probably one object. It's called Bayesian logic. Let me link them all. Oh my God, it's a lion, let me get out of here. So the brain vision is mainly about discovering objects. Discover an object, you get a pleasing sensation, wow, let me get out of here, oh it's a mate, let me chase it, whatever. Okay? And the artist can take advantage of this. Whether you're a Renaissance artist, next slide. Now another example of grouping is here. Most of you instantly see parentheses. How many of you see parentheses? Raise your hands. But you can also see it as hourglasses. See that? Right? But you prefer parentheses because most natural objects are closed boundaries. It's called the Gestalt principle of closure. The Gestaltists knew about this. Artists exploit this. Next slide. Renaissance artists use, look at that azure here. Same azure, same azure, same azure, and the brain links these in the mind and says, wow, okay? And it's pleasing to the eye, and the Renaissance artists knew this. The same brown, same brown, same brown, repeating everywhere, okay? Next slide, a famous Van Gogh painting. Here's this kabuki, this person. Van Gogh put this mat there. Notice how he repeats the same colors and the same textures in the mat to create this pleasing sensation, little realizing he was taking advantage of the fact that your brains evolved up in the treetops to detect lions. That's what he's exploiting here, without knowing it. Next slide. You can use multiple principles in one image. Here's a medieval stone sculpture from India. 2 celestial lovers. Notice how there's a lot of things going on here. First of all, of course, big breasts and hips and all that, but also grouping. Look at how the lines flow into each other. And the flowing of the lines into each other is a metaphor of the lovers mingling with each other, their souls mingling. Notice also how her head is tilted back, exposing her neck. her throat. This is a gesture of ethological vulnerability, meaning you can sink your fangs into my throat, okay, like Dracula and all that, okay? So, in other words, you're saying, I'm completely vulnerable, take me, okay? But the funny thing is, she's saying that, and look at him, he's trying to peel her jeans off, right? And yet look at the way she's holding on to it, saying, no, not yet, not yet. So there's a coquettish aspect to her behavior. So there's this palpable erotic tension being built up in the image, and all of that is unconscious. It's hitting your brain, hitting your limbic system. And you say, my God, it's so beautiful. You didn't notice all that in the beginning when you looked at it. You just said there's a couple of lovers. Okay? Even the trick of that head being that way and this head being this way is very deliberate. It's to allow that grouping. Okay? Next slide. The third principle I want to tell you about is called isolation, and that is every artist knows that a little doodle or a sketch can be much more evocative and beautiful than a full color photograph. Right? You can have a little doodle of a nude by Klimt or Rodin, right? And you look at these, they're much more beautiful than a full color pinup, Playboy pinup or something. Well, why is that? You say, Dr. Ramachandran, you say it's all about activating the visual areas. If you have a real photograph of a nude, there's color, there is texture, there is hair, there is depth. It's going to activate all those areas. It should feel really good. It should be a great work of art. No, I'll tell you why. It's because, take a great artist and who's doing a doodle, a nude. Picasso, Klimt, Tracus, Rodin, any of these people, doing a little doodle of a nude, and you look at it. The essential information about her being feminine and sexy and a nude is in the outline. It's not in her skin color. Her skin color is the same as yours, or mine, or anybody here, right? The key information is in the outline. So what you're doing is by putting all the skin color and hair and all that, you're distracting the brain's limited attentional resources. So ultimately it has to do with attention. The fact that even though you've got 100 billion nerve cells in your brain, you've got a limited attention. You can pay attention to only one thing at a time. So what the artist is doing, be it Klimt or Rodin, Rodin you think of sculptures, but he also did wonderful little doodles of nudes. Isolating the critical information and giving you peak shift in that, so it's saving your brain a lot of labor. You don't have to pay attention to texture and color and hair and all that, and you home in instantly on the outline, and you say, wow, the rasa of a nude or rasa of a portrait or whatever, okay? Next slide. And how do I know this? Look at that. Comparison. That's a drawing of a horse by a normal 8-year-old child, and it's hideous. Okay? It looks like a, like a cardboard cutout. There's no depth, there's nothing. This is a 6-year-old autistic child named Nadia, who can't even talk. Look at that horse. It's leaping out from the canvas. She's retarded. Leaping out from the canvas. It has got the rasa of a horse. Here is a horse by Leonardo da Vinci. When I polled audiences like this, many of them actually said, this is better than this. It's got kind of too many lines. You know, like that saying about Mozart, too many notes, like the king said, It's got too many lines here, right? This one, on the other hand, is perfect. Now, here's a paradox. How can a retarded child who can't tie a shoelace, who can't talk, create this wonderful horse? The reason is the principle of isolation. What artists, the famous aphorism, less is more in art. Why is less more? Because this child, in Nadia, all the other brain modules are not working. But the right parietal of the brain, which is sensitive to artistic proportion, sense of proportion and all that, we know that, because when that's damaged, you lose the ability to paint and draw. That alone is spared in her. So she spontaneously allocates all her resources to that one area that's spared, which is about artistic proportion. Therefore, what you and I and all of us have to learn, spend years learning, to ignore all the irrelevant distraction and pay attention just to the outline, she does it instantly. She's got a module created just for rasa, which is actually hyper-functioning and maybe hypertrophied in her brain. Next slide. Now, the next principle I want to tell you about, the last one, is the most difficult to understand. It's called the principle of metaphor. Now, you all know what a metaphor is. We just talked about Shakespeare. In poetry, you know what a metaphor is. It's taking two seemingly unrelated realms of discourse and developing a link. Juliet is a young lady, is the sun, is a celestial object. Nobody would think they're related, but Shakespeare linked them. And it's beautiful when he does that. Now, what people don't realize is visual artists also do this. Take this young lady. She's a celestial nymph from Khajuraho, near the bottom of the temple, aspiring to God, looking heavenwards. This is my last principle, by the way. Aspiring to God, looking heavenwards, pulling her own finger, so there is this sort of eroticism in there, okay? But also notice there is this branch or bough with mangoes. Those ripe mangoes is a metaphor of her youthfulness and fertility. So the mangoes represent fertility, the fecundity of nature, and they're echoing her breasts and her youthfulness and fertility and fecundity. So it's a very subtle artistic trick frequently used in Indian art. The other principle I want to tell you briefly is a principle called peekaboo. And that is, everybody knows that a nude seen behind a diaphanous veil is much more attractive than a Playboy pinup. Well, you say, that doesn't make any sense. After all, if you show the whole photograph, it's going to hit your brain big, but if this is all concealed, how come it's more beautiful? The reason is, our brains evolved in camouflaged environments, trying to discover objects. So you have to give the brain incentive for finding an object, peekaboo, for discovering a hidden object. So if the artist deliberately hides it for you, and the brain has to work to discover it, that's actually pleasing to the eye. Wow, there's an object there. Let me look at it. Wow, there's something hidden there. Let me find it. It's a predator. It's a mate. It's a prey. So it's all about your ancestors up there in the fog, in the treetops, trying to mate in the fog. Trying to find a mate in the fog. And you have to make it pleasing, otherwise you'll give up too easily, right? Now, Indian art uses the same principle, but slightly differently. Instead of using diaphanous garments, what they do is they have nudes with the jewelry, with the necklace, just hiding the nipple, right? And you look at it and you're just waiting for it to reveal it. And you say, this builds up this erotic tension, and this is what I call the peekaboo principle, okay? Next slide. Going on to metaphor, this is one of my favorite slides. Ignore all this Baroque stuff in the background. This is Pala, from the Pala dynasty, right, from eastern India. Shiva and Parvati, the celestial cosmic couple, right, and cosmic couple seated there. Notice how she's sitting on his right lap. They're looking at each other completely enraptured, okay? And look at how she has her left hand draped around him. He has his right hand around her breast. So there is a clear sexuality in this image, an understated sexuality. That's just the surface, but there is a lot of metaphor here. If you read Heinrich Zimmer, writing about Indian art, he'll talk to you about this for 2 hours, and I don't have 2 hours. I'll tell you in 1 minute what the metaphor here is. What the artist is trying to convey is, here's Shiva and Parvati, the cosmic couple. But Hinduism is ultimately monotheistic. Very few people realize this. And by the way, I want to say at the outset, I'm not trying to preach here. I'm not a practicing Hindu. I'm a scientist, agnostic. But you have to understand the religious metaphor to understand the art, okay? And what the Indian artist is doing here is he is saying, it's as though they're saying, although seemingly two, right, they are fundamentally one. They are two aspects of one divine principle, namely God. And then at once, it's as though this God or unity has unfolded itself into a duality for the sake of all of you lesser mortals. Okay? For the sake of the universe and all its beings, the Supreme Spirit has unfolded into this duality of Shiva and Parvati, and then it immediately becomes a metaphor of all the polarities and dualities and antagonisms and distinctions that characterize the phenomenal life, such as male and female, yin and yang, electron and proton, matter and antimatter, right? Creation and destruction. Okay? That's the metaphor that the artist is trying to convey in that image, and it's brilliantly conveyed. Okay? Next slide shows you an even better example, the greatest example of all, and that is one of the greatest works of art of all time. Rodin said it is the greatest sculpture he has ever known, and that is the Chola bronze Nataraja from the 11th century in southern India, showing Shiva as the cosmic dancer. And what he's doing there is his dance is supposed to be the dance of the cosmos, the dance of the universe, the eternal rhythm of the universe. And Again, mind you, I'm not preaching here. This is just, I'm trying to tell you what the artist is trying to convey, okay? It's very important to be very clear about that. And this ring of fire, punctuated by these flames, represents the cyclical nature of the cosmos, creation and destruction. And notice how Shiva is right at the center of it all. And the artist has very cleverly combined two seemingly antithetical elements, like there is dance, there is tremendous frenzy, there's frenzy and activity of the universe, okay? Which is what the universe is, the phenomenal universe. At the same time, complete tranquility and poise and calm. I am right at the center of it, just like your own human soul is, right? And I'm just the spectator, but I'm also the creator of all this frenzy around you, okay? So that's his expression there, supremely tranquil and blissful. And this wonderful poise, his leg raised there, gives him a wonderful sense of balance and poise. So the artist is a genius because he's combined this frenzy of this dance of the cosmos with this calmness and dignity and tranquility of God Shiva, who's at the center of all this activity, okay? At the same time, there's a lot of other metaphors going on here. Look at his right hand. He's holding a drum, a tambour. That is the rhythm of creation, okay? The rhythm of creation. And on the other hand, balancing it exactly is a flame, on the other hand, destruction. So creation and destruction balancing each other out perfectly, okay? Then look at his foot, bent slightly to give him that wonderful sense of balance, crushing this, I don't know how many people in the back can see this little hideous dwarf. And that dwarf is the dwarf of ignorance or illusion or Maya, okay? So Shiva is saying, get rid of this illusion. Now what is that illusion? The illusion is that all of you lesser mortals have, including me. The illusion is that the universe is nothing but the mindless gyrations of atoms and molecules. That's it. And we're here for a short while and we're dead, we're gone. Kaput. Okay? When you get rid of that illusion and realize that all of this is just part of this great dance of the cosmos, the great dance of Shiva, and you're really part of the cosmos, you're not separate from it, you're not an aloof spectator watching this dance, you're part of the cosmos. When you get rid of that illusion and seek salvation under my foot, he's pointing to his foot and saying, seek salvation under my foot, then you will really be released from bondage and achieve enlightenment and union with Shiva. And realize all is illusion. Okay? Next slide. I want to conclude, briefly, many people ask me, you're talking about Indian art, what about Western art? These principles are not unique to Indian art. It's true of Indian art, Western art, Tibetan art, any art, okay? But there is something unique about Indian art, which is it has this wonderful transcendental quality, many of the sculptures, as though it's not of this world. How does the artist achieve this? I have no idea. One trick they very, very often use is they leave out the pupils in the eye, and that gives it this otherworldly quality. But they haven't done that here. He's just closed his eyes. It's the way he's sitting. There's an image of the Buddha from Ceylon, from about the 10th century. And look at that wonderful sense of grace and poise, you know, and saying, don't worry, everything will be fine. You'll all be fine, we'll all be fine. Don't worry, okay? Okay, he's the Bodhisattva, the enlightened one, okay? Next slide. I want to tell you about another principle, which is symmetry, which I won't go into. I mean, every child who has played with a kaleidoscope knows that symmetry is important. This is because biological objects, why do our brains like symmetry? Is it just coincidence? No. It's because most biological objects, faces, animals, prey, predator, mate, are symmetrical. So your brain has an early warning system. My God, that's symmetrical. Look there. Maybe it's a lion. Maybe it's a mate. Look there. Okay, it's an early warning system. Artists use this. Kaleidoscope. Islamic art. You know, all those mosaics and all that. Okay? Or the most immortal work of art, the Taj Mahal, which the great Emperor Shah Jahan built for his beloved Mumtaz Mahal. It's an immortal symbol of love. Okay? And again, it's symmetry. It's all about symmetry. Last slide, I'm concluding, which is, when I was a medical student, what I was taught was, You know, certain things, if you're going to get into research, you're going to become a scientist, you're going to do research, certain things you stay away from. Like, what is consciousness? What is free will? What is the meaning of art? What does it mean to fall in love? I mean, all the things everybody's interested in. You sort of stay away from if you want to get tenure. Well, fortunately I have tenure, so I can pursue these questions. And what I'm trying to say is, given all of these wonderful new imaging technology, by studying the right kinds of patients, whether it's Capgras syndrome, phantom limb, or whatever, or even by thinking about some of these issues like art, you can begin to address many of these lofty questions, such as even what is the meaning of art, which until now has remained the province of philosophy. Thank you. A gentleman asked the question, many of the examples I cited involve starting with a real object and doing something with it. What about completely abstract object? Sorry, completely abstract art, say Kandinsky. Okay? Now I want to say, by the way, in Indian art, you know, centuries ago, they had a movement called tantric art, where what they said was, to hell with any object. We don't want to represent anything. Let's have geometric designs to align forces in the mind, allow you to seek God. Very similar to the language Kandinsky uses. Okay? What's going on there, I think, is one of the principles I didn't go into is things like contrast. And I only talked about a few of the principles. What the artist is doing is creating object-like entities, and again, stimulating certain brain centers where you say, look, this is pleasing, this contrast, this positioning of the objects. And also I want to say, I'm talking about rules of thumb. I'm not talking about absolute laws like laws of physics. And a given artist may choose to deploy 3 of these laws. Another one may deploy 6 or 7 of them. And it's up to the genius of that artist and intuition of that artist which laws he deploys and how effectively he deploys them. And for the record, I'm not a big fan of completely abstract art. I mean, I like I don't like purely representational. I don't like completely abstract. I like the art that lies at the interface, which is most evocative, I think, because we're all like seagull chicks. Yeah. Very good question. No, they're not stupid, but what's happening is their mothers told them they shouldn't like it. To put it differently, their basic limbic mechanisms in the brain are still hyper-responding to Picasso compared to a normal face. But then another part of your brain, you see, your brain is very modular. There are lots of brains. In your brain, there are about 25 brains. I don't know about you, but generally there are 25 brains. Okay? And what's happening is some of these are saying, hey, this doesn't make any sense. How come a woman has 2 eyes on one side? I am aroused by it, I like it, but I shouldn't tell anybody about it. Emperor's new clothes, you know, I shouldn't tell anybody about it. So what I'm saying is the basic circuitry may be there in all of you to respond to Picasso, to respond to Cubism, but there are so many layers before you finally say, yeah, I like it, to somebody, that those somehow you're engaging in denial. Okay? And denial is a very common phenomenon in human nature, not just about art, but I was telling a student the other day, you know that half the human race is in denial about their stupidity. I'll tell you why. Because if you do polls, you find that 95% of people think their IQ is above average. Now this is mathematically impossible. Okay? So this means 45% of people who are stupid are denying that they're stupid. Okay? And this may be equally true of response to art, you know. We have not done that yet. My prediction is it doesn't matter, because what you're tapping into is an earlier visceral reaction which should be same for both of them.
But you were saying it had to do with the mother. Now suppose your mother likes Picasso and you don't.
But the galvanic skin response is tapping at an earlier stage before it gets to the thinking part of the brain, which is starting to think about your mother and saying and all that. So my prediction is, even though he says he doesn't like it, his skin can't lie. So it's like a lie detector. The galvanic skin response is basically the same as a lie detector. So this guy is lying. He likes Picasso. Okay? So you can actually, you know, put these in art galleries and tell somebody You know, you can tell somebody, you know, you have to pay $1 million for this, whether you like it or not, because you know, your skin is telling you like it. You know, so that's my response to that. Yeah. Oh, absolutely. I stand corrected. I was using the example of just blindly aiming a camera and just taking a photograph. Certainly using photography, you can do clever tricks, emphasizing some aspects of the image, not emphasizing some aspects of the image, and then of course you have a work of art. So I was just using, it's a caricature, yeah. The question is, the people with synesthesia, these subjects, these 1% of the population who when they see 5 they see red, when they see 6 they see green, when they see 7 they say blue, is it the concept of 7 or is the actual visual image? The answer is, it depends on the subject. Of the 3 or 4 subjects we've tested, the most common is, it's the actual visual grapheme, as we call it. If you draw 5, they'll say it looks tinged red. But you give them a Roman 5, right?
5 objects, a symbol.
I'm coming to that. You give them a Roman 5, they say it doesn't look colored. Or you give them 5 strokes of the pen. So they got the concept of 5, doesn't look colored. So it's the visual, not the grapheme. But of the 4 subjects we tested, 1 subject, we found the opposite. For him, if you show him 5 cluster of 5, he'll say that's also tinged red. Or if you give him a Roman 5. The reason is, I only showed you the fusiform gyrus. If you go to the next stage of number processing, where it gets more abstract, you get to the angular gyrus, okay, to the front of the angular gyrus. And Zecchi's next stage of color processing is also in that region. So you may get cross-wiring at different stages in different people. And in that guy, it's the concept of the number that evokes the color, not the visual appearance of the number. This is why we think we've got this wonderful new area of arena of research. It even overlaps with art to some extent because many artists are synesthetes. You know, Kandinsky certainly was, and another chap, was it Pollock? Somebody here may know, yeah. And many artists, and Nabokov, many novelists, disproportionate number of them. And I think this is because they can form more associations in their brain than lesser mortals like us, you know. Very good question. The metaphor stuff is kind of like in the borderline between conceptual and perceptual, right? It's kind of neither here nor there. When you get even further and start talking about somebody who's deliberately perverse and takes, you know, a toilet bowl and say that's a work of art, then you're getting far away from what I can do as a scientist. I can say, I can come right up to here, and then you're on your own, you know? Okay? It's a very good question. What you're asking is, these voluptuous goddesses and all that, you know, is it modulated by sex hormones? I bet your limbic response will be much higher, your GSR, if you have a high level of testosterone or some other transmitters in the brain. Again, it's an interesting question. It hasn't been...
Change the perception?
It may indeed change it. It's a good question. We have not looked at that. Yeah. Yeah, no, that's a very good question. You see, this harks back to what I was saying, namely, maybe these great artists are tapping into form primitives. We don't know what the brain uses as the alphabet to represent form. The gull chick likes that long stick with the 3 red stripes. It fetishizes that. Similarly, it could be we have certain form primitives, you know, maybe Platonic primitives, who knows? And the artist can tap into that and exploit that. But none of this has been studied in a proper manner scientifically. That again is related to Jungian archetypes, except he starts getting mystical and saying there is some mystical force. But if you ignore that aspect of it, certainly there could be archetypes, there could be mechanisms in the brain which are especially active when seeing certain types of universal shapes. You know, that's a very good question. That's a good point. I mean, there's a big jump between the creators obviously have an extra something in addition to the cross-wiring, which enables them to do these leaps. Whereas the appreciators can only go so far as seeing a great work of genius when it's presented to them, but not themselves. So it's all a little bit woolly. I mean, I can't really get at the neurological basis of the creator versus why is Mozart, Salieri can understand, appreciate, enjoy, but is tormented because he can't create like Mozart, right? But there are some people who can't even appreciate Mozart. So at least we're better than them. Yeah. Sorry. One more question. No. I mean, not necessarily, you see, because, well, no, because the world is gyrations of atoms and molecules, and we can understand those things, and we can make progress, we can send people to the moon. That's all science, and we can understand that. Nobody's saying, all that Shiva metaphor is saying, behind these appearances is a deeper reality which science cannot access, and maybe there is. You know, as I said, I'm not going to dispute that. To me, it's beautiful as a poetic metaphor, and it works for me, and it's beautiful, you know. And I think somebody said, I don't know who, maybe it was Rodin, that there is no better instantiation of the concept of God than the Shiva Nataraja, because it doesn't appeal to a personal. See, a lot of people, you know, the English, going back to the English, listen to this, you know, the Victorians coming to India, looking at all these, said, monstrosities, you know, multiple arms and monstrosities, not realizing this is all metaphorical. No Indian, not even an Indian peasant, thinks there's a man dancing with 5 legs up in heaven. Okay? This is the stupidity of this Englishman who came there, confusing metaphor with reality. Right? It would be like an Indian scholar reading Shakespeare and saying, what a stupid man Shakespeare is, thinking Juliet is full of fire and flaming up, you know, because he says Juliet is the sun. It's the same error, okay? Confusing metaphor with reality. Sorry, I don't know if I answered your question, but, yeah. Sorry, your question, yeah. Okay, one more and then we're done, right? Okay, very good question. All I can say is with music, I know much more about Indian music than Western. Certainly principles like grouping apply. Like for example, why is it you talk about harmony, right? Very often a single object produces overtones, okay, which are in fact have that relationship. They're harmonics, right? And the brain, the auditory brain is trying to discover objects too. That's why harmonics are pleasing. Now going back to peak shift, India, it's all about raga, it's about melody, it's not about harmony. And what you're doing with melody is, you're stretching it, doing hyperbole, doing peak shift. So there is a raga called Raudra Rasa, where it produces anger. Another raga which is supposed to be like Darbari Kannada, which is all about sort of sorrow and it's mellow. And what you're doing is taking primitive primate vocalizations, like the infant separation cry, right? The infant starts screeching when it's separated from the mother. It's a very primitive, powerful thing built into all your brains. And when you listen to Darbari Kannada, what the artist has done is to do this thing, this peak shift, with that infant separation cry. And you just sit there crying, right? And you're one with God, you know. So that's what that's about. But we haven't looked at it as carefully as with visual art. That's fine. Thank you.